So, good morning. Good morning, Kate. Don't mind me. Good evening, everyone. So, we are going to look at Taylor series and Maclaurin series. So, there are two keywords there: series. By now, you guys should know what a series is. A series is just a list of numbers that follows a definite pattern, and this definite pattern are bounded by a set of rules. For example, two, when you have two 4 6, this is a series because this thing it follows a definite pattern, so you know the next after 2 4 6 is 8 and so on. So for series, when there's an addition of plus, that is what makes it a series. You get it? So that is what makes it a series. So we have a general form of Taylor series. And what is that general form? Are we to prove it? Should I prove should we prove it? So you just know this formula. So what is the formula? This is Taylor series formula. F of x is equals to f of c plus f prime of x into bracket x minus 6 raised to power 1 all over 1 factorial f prime of c open bracket x minus 6 square over 2 factorial. So this is the general form. So you can now say plus dot f n of c, then x raised to power x minus c raised to power n all over n factorial. So this is the general form of Taylor series, and it was gotten. Let's just try to prove it. Let's say we have f of x. This is the general equation for function f of x equals a plus bx plus cx squared plus dx cubed plus dot. So if when you differentiate it, f prime of what of x, you get, when you differentiate it, it becomes b plus 2cx plus 3d x squared plus dot. So when you put x as 0, this one becomes f prime of 0. So if you put x as 0, it becomes b. Do you get? So when you differentiate this one again, it becomes f prime of what x is equals to, this one will give me 2c plus, I can see 3.2dx plus dot. You know, here too you still be differentiating. I don't know if you can see it. So when you make c the subject, when you put f prime of 0, it becomes 2c plus, I'm not meant to do this, so x is 0, so this one will give me 0. So it becomes, when you make c the subject, c is what f prime of 0 all over what 2. So you do the same thing for the d. That means you differentiate this one again. So this one becomes f prime of x. When you differentiate this 2c, you get 0. So this one will be 6d because the x will disappear. But you know the rest will still be having. You notice that this 3.2, I can change it to 3 factorial. So the other one, you don't need the soothsayer to tell you that the other one, if you write the function up to maybe ex raised to power 4, you notice that the fourth one will be 4 factorial ex squared and so on. But because of when you put x as 0, all other things aside this 6d will give me 0. So that is why this will be f prime is equals to 6d plus 0. So when you make d the subject, d is equals to f prime of 0 all over 6. So once you now put the whole equation, all this inside here, so this one becomes f of x is equals to, what is my a? My a is just f of 0, because if I put 0 here, all other things will give me 0, but the only thing that will remain is a. So therefore my a is f of 0, then plus what is my b? My b is what? F prime of 0, then x. That is my b. My c is what? My c is f prime prime of 0 over 2. You can call it over 2 factorial, because 2 factorial and 2 are the same. That is plus f prime prime of 0 over 2 factorial x squared, because yes, that is my c. Can you see it here? Cx. Then plus d. D is f prime 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 of 0 all over 6 is the same thing as 3 factorial. So that is how you do it. Because this 6 here, if you look at it, look at this place here, we have 3 times 2, which is 3 times, which is the same thing as 3 factorial. So you don't need to do others. Others will still give you 4 factorial and so on. So that's how they got this. Stylishly, we have done for this for Maclaurin's. When c is 0, this equation that I gave you here, once it is 0, so once c is 0, that is Maclaurin. Take note, once c is 0, that is Maclaurin's. But once c is not 0, that is Taylor. You see that, look at this case now. This one and this one are the same thing, but just that here it is 0. This is Maclaurin. This one is what? Taylor. Because that is it, as simple as that. So you know that if c is 0, this one becomes f prime of 0. See, have you seen? C is 0, x minus 0. Have you seen it? So that is how it is. That is the difference between Taylor and Maclaurin. So if you know Taylor, you have known Maclaurin series. So for example, let's solve this question. If f of x is equals to ln x at c is equals to 1. So f of x is equals to ln x at c is equals to 1. So let's try to solve it. So your knowledge of differentiation is going to be needed here. So you need to know your differentiation very well. You need to know your differentiation very well. So the question is f of x is equals to ln x. So the first thing, because in the formula here, you need to know f prime, you need to know f prime prime. So we need to differentiate, like you need to know f prime. So you need to know f prime here and f prime prime. So the first thing you need to differentiate, that is f prime. But before differentiating, since c is 1, so you just need to find f of c. F of c is equals to ln 1. And what is ln 1? 0. As simple as that. So the next one is f prime of x. When you differentiate ln x, what will you get? 1 over x. So you need to know your differentiation very well. So therefore, my f prime of 1, because my c is 1, my f prime of 1, my f prime of 1 my f prime of 1 is equal. So f prime of 1 will be the same thing as 1 is equals to 1. So sorry, I think I've turned the, let me just try to turn it this way so that it will be normal. Okay. So f prime of 1 is equals to 1 all over 1, because my x is 1, so which is 1. So you differentiate it again, f prime prime of what? X. So that means you differentiate this. When you differentiate 1 over x, you know that normally that is minus 1 over x squared. Let me just try to do the differentiation here. So this is x raised to power minus 1. So this minus 1 will multiply x. That is minus x raised to power. Deduct 1 from the power, minus 2. So that is minus 1 over x squared. So you put c as 1. So that is f prime prime of 1. That is minus 1 over 1 squared, which is minus 1. And so on. So that's how you do. You differentiate minus 1 over x squared again. I think that is it. So then you now recall the formula for f of x. So my f of x, you know that the formula is f of c. And what is f of c? Like this is the formula here, see. F of c plus f prime of c. So what is my f of c? My f of c is what? 0. So that is 0 plus my f prime of c is what? 1. Then x minus 1 all over 1 factorial from this formula. My f prime of c is 1. Then what is my c? 1 at c is equals to 1. So the next one is f prime prime of c. So what is f prime prime of c? Minus 1. That is plus into bracket minus 1. Then x minus 1 all square over 2 factorial. So that is how you do it. Then plus dot dot dot. Plus and minus is minus. That is it. Then plus, you do it for 3 factorial, for 4 factorial, and so on. So that is how you do them. That is for Maclaurin. That is for Taylor series. I think I've explained it to you. I said Taylor series and Maclaurin series are the same. It's just that for Taylor series is at a particular point aside 0, but Maclaurin series is at 0. For Taylor series it's not at 0. So let's now let's do Taylor series for sin x, the popular sin x. So let's do Maclaurin series rather for sin x. For example, if f of x is equal to sin x, find Maclaurin series. You don't need a soothsayer to tell you Maclaurin series. So Maclaurin series is just when the c is 0. That is Maclaurin series. So the first thing you need to do is to differentiate. When you differentiate f prime of x, it becomes cos x. Or before that, you need to do your f of 0. My f of 0 will be sin 0. And what is sin 0? 0. My f prime of x is cos x. Then therefore my f prime of 0 is cos 0. And what is cos 0? 1. From here. Because this is the formula. I said it's similar to this. I proved it here. It's similar to this, just that in this case c is 0. So f prime of 0 is 1. So you do for f prime prime of x. When you differentiate cos x, what will you get? Minus sin x. So when you put f prime prime of 0, it gives me 0. Because sin 0 is 0. So you differentiate it again. F prime 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 of x. When you differentiate minus sin x, you get minus cos x. So f prime 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 of 0 will be minus 1. So let's do the. So the thing just changes from 0 to 1 to minus 1 to 0 like that. So f prime prime prime, that will be of x. So that will be minus sin x, which is 0. So differentiate it again. That is minus cos x, which is minus 1. So differentiate it again. That is sin x, because cos x will give me minus sin x. And what is sin 0? So that's how you keep on doing it. But I would advise you just do like 4 or 5 times. The reason why I'm doing it much is because of these zeros that we're having. So the next is now to put it in the formula. You know, from the formula, it's similar to the Taylor series, just that here to be f of 0. Have you seen? What is my f of 0? My f of 0 is what? Is 0. So you know the formula is f of 0 plus f prime of 0x. What is f prime of 0? 1. That is 1x all over 1 factorial plus f prime prime of 0 is still 0. So that other one will give me 0. See, from here, f prime prime of 0 is 0. So 0 times x squared is still 0, even if you divide it by 2 factorial. So what is my f prime 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 of 0? That is minus 1. So it becomes minus 1x cubed all over 3 factorial. So the thing is that the fourth one will give me 0. The fifth one will give me minus 1. So that is minus x raised to the power 5 all over 5 factorial. So that is it. So that is how it is. So you have seen that Maclaurin's and Taylor series are not difficult. So all you just need to know is to know how to differentiate. They are the same. They are very similar. So you see for the Taylor series, let me go back. for the Taylor series only having C there, you would have given at the point C, the one that we did in X as C is equals to 1. So you differentiate it. Instead of putting X as 0, you put X as what? C. And what is the value of C? 1. So that's what I did here. So when I'm now done, I now record this formula, that the formula is f of C plus f prime of C x minus 6 raised to power 1 by f prime prime of C x minus 6 square raised over 2 factorial. So that's what I now substituted here, because I know that my C here is 1. So that is x minus 1 all square over 2 factorial, and this one x minus 1 raised to power 1 over 1 factorial, and this one is length 1, which is 0. So that is for Taylor series. But even it was for Maclaurin series, this C here would have been 0. Do you get? This one here would have been 0, and here it would have been length 0. So that is that. So Taylor series and Maclaurin series are not difficult. So I want you guys to try this. Do find the Maclaurin series of cos x. Do it to f raised to power 4. So find the Maclaurin series of cos x. So you don't need the associate. If they say Maclaurin series, it simply means at C is equals to 0. But if it is Taylor series, it simply means that C is equals to another value aside 0. So that is all. So if you have any question that you don't really understand, feel free to do that in the comment section. And please try to do this question. F of x is equals to cos x. Find the Maclaurin series. And also find, the Taylor series at x is equals to pi over 4. No, should I say pi over 4? No, let me say pi over 2. So find the Taylor series at x is equals to pi over 2. At c is equals to pi over 2 rather. And do the Maclaurin series. Do the Maclaurin series of cos x and do the Taylor series at c is equals to pi over 2. Automatically for Maclaurin series c is 0, but for Taylor series c is anything aside 0. So like I said earlier, if you have any question, please feel free to do so on the comment section. Welcome to Brain Educational Consult. Mr. Brain loves you. Bye.